Welcome, welcome. Come one, come all to the International Exhibition of FME. Today, our merry band of safers are going to provide you with a tour of the fair's finest, demonstrating the most common real-world data integration scenarios that we encounter with our users every single day. A quick bit of housekeeping for today's presentation. If you do have any questions at all during the presentation, we encourage you to type them into the chat, and our awesome team of safers are going to be helping to answer these as we go. Before we begin though, let's do a brief round of introductions to our presenters today. My name is Brian Pont, and I'm the Director of Customer Success here at SAFE. I am not a fair rookie. I've been to a World Fair before in my life. Actually, it was the Vancouver Expo 86 that I attended as a little kid. And my only memory of that is driving around to all the various different pavilions and trying to eat my weight in cotton candy, which was a big, tall task for a little guy. And now I'm going to share it off to Chris. Chris, do you have any favorite memories of fairs in the past?
Yeah, so my name is Chris Berger, and I'm an FME technology expert here. And my favorite memory would be from a field trip back in elementary school, where I got to watch the Superdogs show at the local fair called the PNE. How about you, Mark?
Hi, I'm Mark Warren. I'm an FME server expert, and I love going down the water slides and fairs, but I don't like roller coasters. And to you, Laura?
Hi, yeah, my name is Laura. So I'm one of the team leads for our FME server experts group here at SAFE. Yeah, if I had to pick a favorite memory from a fair, I think I've always enjoyed whenever there's a petting zoo at one of those, just getting to see all the little farm animals and all that. So I think that's up there. And yeah, to you, Jen.
Yeah, so I'm Jen. I'm an FME cloud expert at SAFE. So anything to do with FME cloud or cloud related, I'll be supporting you. And my favorite memory is probably back where I'm from, every October, the fair would come to town, but we would call it the MOP. So I really liked going to the MOP every autumn.
Fantastic. Well, let's get going. And the first thing we wanted to touch on is just the fact that our world is incredibly filled with data. We have it within our organizations. We're trying to make use of it all the time. And why we're all here today is because data integration can really help us make better informed decisions with all that data. And so we're going to look at a number of examples today. In fact, we're going to look at 6 of the most common scenarios that our FME experts see. And our goal is to really inspire you, give you ideas that you can take back to your own organizations. And in fact, stay tuned tomorrow because our data acrobats are going to take a deeper dive into all of these different scenarios and help you recreate them yourselves. Now let's jump into the first set. The first set is streamlining operations. And organizations are always looking for ways to streamline. We see this from every level of government to utilities, energy, engineering firms, natural resources. Every organization and industry we touch upon is always trying to improve. And when it comes to data integration and how it can help, we primarily see the automation of manual and repetitive tasks as just a fantastic way to optimize. Implementing them as standardized and efficient processes can really set yourself up for the future. And automation also helps to ensure that the right decisions is available to you at the right time and to the people within your organization, and it really helps to drive your business forward. And one of the best results is equipping everybody with the ability to make data-informed decisions. You can also give back hours a week to people responsible for moving the data and ensuring that it can be done efficiently and hands-off. Now, let's explore this further with 2 examples from Chris and Mark. Take it away, Chris.
All right, let's take a look at a common example of a streamlined operation, digital plan submission. Digital plan submission is a phrase most commonly used by local governments who need to receive plans from land developers to input into the city's GIS. This process typically involves validating a data model and converting it from CAD to GIS, but the concept is solid for many industries, where we see any situation that requires data to be submitted from one party to another or one organization to another. Generally speaking, digital plan submission is advantageous in any situation where you don't really need to pull the entire data set from one system into another. So let's zoom into a CAD to GIS local government example to explore this further. Let's take a look at what it's going to look like before fully automating this process. Typically, you'll have a GIS professional who receives a CAD data set from a land developer, and they'll manually run through a workflow that validates the data. Upon passing the validation, the data gets loaded into a GIS. But really, how often does that CAD file pass the validation the first time? In many cases, it doesn't. And then the GIS professional has to type up an email or make a phone call and explain everything that went wrong and what needs to be corrected before the file can be resubmitted. This is really tedious and time consuming and provides opportunities for human error. So let's automate the process. Now the land developer goes to a web page, they upload their data set, and they either get a notification that the file passed the validation and has been submitted, or it fails, and they get a clear, concise report of what exactly needs to be corrected before resubmitting. In this situation, the GIS professional doesn't even need to be involved at all, except to see a report of what's been submitted and whether it's passed or failed at whatever interval they deem appropriate. This dramatically reduces the time spent on digital plan submissions each week and ensures a smoother experience for both the person submitting plans and the GIS professional as well. This concept can be applied to any situation where valid data needs to be provided, whether it's a municipality submitting address data to their local county for an authoritative 911 data set, or a group of organizations contributing to multi-jurisdictional data sharing initiatives. Realistically, digital plan submission works in any situation where data needs to be translated between systems or validated in some way before it can be used.
Streaming data is becoming more and more mainstream, where it's connecting business decisions to real-time data. But what are streams? This term broadly refers to a series of continuous data points that originate from one or more sources, such as sensors, devices, web and cloud services, and applications. This term is often used in the context of event streams, where data is streaming continuously in response to an event. The Internet of Things, or IoT, is one of the top sources of event streams. For example, sensors that power smart cities, SCADA, and geolocation. You've likely heard of other FME users having success with this kind of work, such as Pelmorex, Iowa Department of Transportation, and Grand Leon, who we've all featured in the past. Sensors can mean business applications like insurance claims and bank transactions, and even digital information such as social computing and customer call logs. In all of these cases, decisions can be made at the speed of data.
Let's take a look now at our second set of scenarios, data modernization. Our world is changing rapidly, and organizations are modernizing their infrastructure to keep up. A major goal when modernizing is maximizing the value of all that available data. And we've seen many different legacy systems being replaced during these projects. One of the major improvements is that the data being handled by these new systems is becoming more accessible and more connected. Now let's pass it over to Jen to talk about a few of these scenarios.
So more and more, we're seeing customers using FME to migrate to cloud systems, such as data warehouses, databases, and cloud storage. There is significant appeal in reducing the time and cost of infrastructure. No longer do organizations have to wait months to procure and provision hardware. The cloud enables them to quickly launch and scale modern services and applications. In these migrations, data integration is a key consideration for success, and both consolidating data and removing silos are key planning considerations. Location data used to be the specialty of the GIS department. In our position as the creators of the data integration platform that has the best support for spatial data, we've had a front row seat in witnessing the steady emergence of a new appreciation for the skill sets of these GIS professionals. Spatial data is now mainstream, but it has always been useful. For commercial businesses, they can identify where their customer base is, and therefore they're able to decide where they should build their next location. Spatial data also allows you to find where is the problem that needs solving, and where is the nearest crew that can take care of it, for everything from potholes that need fixing to infrastructure that has been damaged by a natural disaster. Spatial data also influences planning decisions, being able to provide information to help answer questions like, how will the surrounding environment be impacted by building a dam? Today, spatial data is even easier to access and interpret with modern systems. Cloud-first data warehouse providers like Snowflake and Google BigQuery are ensuring the support of spatial data right out of the gate, and they have the volume capacity to handle it. In the last few years, especially the last year, we're seeing a large push to the cloud for spatial data among our customer base. In part 2 of this presentation, we'll take a look at how the FME platform is able to migrate data to the cloud and integrate with these cloud-based systems.
The last set of scenarios is focused on cultivating data cultures. And our world is producing more data every single day, and making sense of it can be very tricky. Organizations that embrace a culture around the importance of data are growing by leaps and bounds. And taking a step back and looking at the big picture of how data is being managed, produced, and used is key. In practice, this means connecting systems, sharing trusted data, and providing information that empowers decision makers. These are all key facets to a successful future. Let's pass it over to Jen again to showcase one example of this, and I'll follow up with a final example for today.
So application integration is a technique that allows customers to cultivate their data culture. It not only enables data to flow freely between various applications, but an application integration workflow opens the possibility to expand on key projects between teams and external vendors and improves operational efficiency while delivering actionable insight. Like data integration, the goal of application integration is to ensure that data users can access the information they need in whatever system makes the most sense for them. It eliminates the duplication of manual data entry and bridges data between systems. Data integration is performed on data that is at rest and aims to bring together data from a variety of sources to create a unified data set. When data in one database changes, it can trigger an event-driven workflow to update another database. It can also be synchronized or migrated on a schedule. Application integration uses APIs to communicate at the transaction level, also using event-based triggers or schedules to inspire either the application itself or another application to take action. One example of this that we've seen is when a city wants to roll out a new garbage and recycling program that provides advantages to citizens who want to reduce their household waste. They enable the citizen to enter their garbage cart size selection on the city website, and this triggers their scheduled cart to be delivered, and those who choose a smaller cart are given a smaller annual utility bill. In the past, this data would need to have been passed along from department to department, with data entry required in each new system. In the second part of this presentation, I'll take you through some of the application integration fundamentals so that you can start using FME in your own application integration workflows.
Hi, yes, I have the privilege of introducing our guest speaker for this segment of our talk. Banu has degrees in both GIS and computer science and is an FME certified professional and has been since 2020. She's a GIS developer with the city of Airdrie and has over 5 years of experience working in local government. She enjoys solving real-world data integration challenges, and besides work, volunteers with the GIS Corps and HOT in crowdsourcing missions. She enjoys cooking, hiking, photography, and gardening in the summer months. And she's going to be speaking to us today, talking about how City of Airdrie built an integration for Alberta One Call and CityWorks using the CityWorks API and FME server.
Hello everyone. Thank you for joining this presentation today. It feels great to meet you all virtually. This session is about how we integrated Alberta One Call and CityWorks using CityWorks API and FME. My name is Bhanu Vedula and I am a GIS developer with the city of Airdrie. Airdrie is a vibrant city just 20 minutes north of Calgary with a population of over 70,000. It's a great place to live with small town feel and yet big city amenities. The agenda for this session is as follows. We will discuss a little bit around the background of this project, our challenges, objectives to measure success, the solution we came up with, and some tips that helped us along the way. Many of you are familiar with click before you dig services when you planted a tree, built a fence, etc. Alberta One Call is a regional not-for-profit organization that offers click-before-you-dig communication services to all Albertans who intend to disturb the ground. The request to have buried facilities identified prior to an excavation is called a locates request, and the member of One Call is notified when such a request comes in and are required to mark their underground infrastructure free of charge. The city is a member of One Call and is mandated by legislation to respond to a locate request within 3 business days. With new development, the volume of the tickets increased significantly. Here are some of our challenges. Prior to adopting CityWorks as the asset management software, the locates tickets were manually entered into the system. The sheer volume of tickets up to 500 per month is just overwhelming and an administrative burden to the business unit. With only one locator, the efficiency and planning aspect of day-to-day work is heavily compromised. The city recognized the need for automating this workflow, and since we had FME desktop licenses already, the next logical step was to acquire FME server. The solution consists of 2 FME workspaces, one to create a service request and one to generate a customer report. The workspace uses CityWorks REST API calls to create the service request without manual intervention, an FME server to orchestrate all this in the background. API stands for Application Programming Interface. It's a way to communicate between applications. CityWorks REST API is one such API that facilitates creation of service requests, inspections, and work orders programmatically via HTTP requests. API calls are HTTP URL REST endpoints where data is exchanged via JSON, a lightweight data exchange format. The syntax of JSON looks like a dictionary of key value pairs. Here is a HTTP request with JSON data, and the response is also in JSON, which can be parsed and extracted. This is the workflow of the solution. FME server has a publication that monitors emails via IMAP protocol, notifies a topic, and that triggers a workspace to create a service request in CityWorks. And when the works activity is completed and the service request is closed, a webhook triggers a topic on FME server that triggers a workspace to create the customer report and email it. Here is a screenshot of the email with XML and image attachments. On the right, you have the IMAP protocol settings on FME server. Let's take a look at the first workspace. The workspace is logically organized into bookmarks, and the first section of the workspace has a JSON reader that gets the message from the topic. Next, we have 2 feature readers, one for XML and one for the image. This section of the workspace involves reading the XML tags and mapping them to the CityWorks request template. A vertex creator creates geometry from the latitude and longitude fields and is further projected to NAD83, the coordinate system used by CityWorks to geocode. A Python caller has a code snippet to split the name field to first name and last name, an attribute manager to map the custom fields in the template. A JSON templater puts together all the attributes as key value pairs to make the request. We use the CityWorks custom transformer to authenticate to CityWorks and retrieve a token. The token retrieved is used in subsequent HTTP calls, like this one here, which is a create call to create the service request. A JSON extractor is used to extract the request ID and then merged using a feature merger to attach the image. An add attachment call adds the image to the service request, and an update service request call updates the resolution code to required, thus notifying the locator of a new ticket. Let's go back to our presentation. So the result of the workspace is a service request created with the image attached. This brings us to the second part of the workflow, where a detailed report of the work activity is generated automatically an email to the customer when a service request is closed. To accomplish this, we use webhook functionality in CityWorks. Webhooks are more like API. They allow CityWorks to communicate with third-party applications. They are event-driven, meaning it gets triggered when new data becomes available versus constant polling. There are two components to Action Manager: Action Event and an Action Template. Action Template determines what makes up for the body of the message that is sent. Here, you can see the JSON payload is the request ID, and the action event is what triggers the webhook. In this case, when a service request is closed. Let's take a look at the second workspace. The second workspace also has a JSON feature reader that reads topic message from FME server. It has a file existence checker downloaded from FME Hub to check if a certain file exists in the ticket. And if it does not, it emails the locator to review the ticket. And here we have a series of creator transformers that create the elements of the PDF. Let's take a look at the layout of the PDF. We use PDF page formatter transformers to build the layout. The layout has a title, a logo, customer information, a map, a legend, a disclaimer. And on the second page, we have information of the ticket, any remarks or comments noted by the locator, a disclaimer, and a footer. So let's go back to the workspace. Here we have a series of attribute creator transformers and text adder transformers to build the text for the layout elements we saw earlier. This section of the workspace has all the API calls to extract the information based on the request ID. Here we see a series of HTTP callers and JSON extractors to extract the information we need. Here we are extracting the comments, the customer information, and the custom fields of the ticket. All the elements are styled using a PDF styler for font and size. The PDF is written using a PDF writer and is then emailed as an attachment to the requester. For reference purposes, the locate report is also attached to the service request using an add attachment call. Let's go back to our presentation. So that you can see the result that the locates report is attached to the service request. Now let's go have a demo. Here I have marked this email as unread for demonstration purposes, and you can see these are the custom fields that were built in the template. We have an XML attachment and an image attachment. The XML attachment also has the same tags, same information in the email. The ticket should be read any moment now. There it is. Let's go see the topic monitoring. As you can see, we just received an email with the attachment 1 as XML and 0 as the image. And let's go see if the job has been completed. You can see that the locate service request has been completed successfully. And now we can go to CityWorks to see if a new ticket was made. So this is the new ticket that was just made. You can see the ticket is priority is categorized. The X and Y are converted to NAT83 UTM zone. The image is attached and the custom fields are populated. So once the work activity is done, the locator would attach an image to the service request, and capture any comments. Once the comment is saved, the ticket is now ready to be closed. And when we close the ticket, the webhook triggers the message on FME server. FME server should now have a new service, a topic message, and then the job should run. You can see that the locate report workspace has run successfully. And now let's go back to the ticket. It now has a locates report attached to the ticket. And let's see if the email got sent successfully. Here is the latest email that was sent. And here we can preview the PDF that was generated. It had the logo, the customer information, map, and legend, and the information from the custom fields in the ticket. It also captures the comments that were noted by the locator. And that's it. Let's go back to our presentation. So the results are, we've automated the creation of locate service requests and automated the generation of customer report and email it to the requester. Since it's been a year that we've automated this solution, we had about 9,000 locates requests. That's an average of 600 per month. Using FME combined with the API helped us build a cohesive solution with little to no manual intervention. The results are amazing. These are the comments that we had from the business unit. It takes time to master the API calls and understand how to decode information from the calls. It's an iterative process, and one of the things I found helpful was to use third-party applications like JSON-Lint and Postman to build and test your calls. An FME community is your go-to for resources, knowledge base articles, and troubleshooting advice from a broader user group of FME experts. And we did download FME custom transformers from FME Hub. In a nutshell, if you wanted to build the solution, these are the things that you might need: a service request template, API access, a message queue for webhooks, and FME server publisher privileges, and UNC path locations of the images. To conclude, FME has helped us solve diverse data problems here at the city and continues to be an invaluable tool to tackle everyday data problems. Thank you so much for tuning into this session, and enjoy the rest of your conference. Here are some of our references. Thank you.
For our final example today, let's talk about open data portals. An open data portal is a fantastic way of sharing data, not only with the public, but even internally within your own organizations. Many governments have mandates that help drive this culture of open data. And one of the best benefits of this can be empowering new services and applications being built for the public. To be effective, it's important that users can access exactly the data that they need in the format that they need and the structure that is most useful to them. And that includes the right coordinate system. Because of the value of open data, the popularity and demand for this is growing.
And now I'd like to share an example from the state of Arkansas about how they were able to leverage FME to move their open data portal, previously called GeoStore, now called the Arkansas Spatial Data Infrastructure, over to the cloud. So this story comes from, it happened a number of years ago now, but I think a lot of the elements of this story would still resonate today, especially with more and more people kind of moving to the cloud and it becoming more of a popular tool to use for managing data and everything else. So Arkansas is a longtime user of FME, and their previous open data portal had been based on an on-premises deployment of FME server using an SQS server as well. So they came to us with the news that they were going to be migrating that entire stack from on-premises out to the cloud, and they wanted to know if FME could help and could play a part in that one as well. So their GIS portal was quite a popular one. So they had thousands of monthly downloads and many different users that would come to their GIS clearinghouse to download data in a number of different formats and everything. So their move from their previous on-premises deployment took about 3 months total to take all of their data from wherever it was, to move it out into the cloud and create a new portal that was also cloud-based there. So here's an example of what their new portal looks like today. So you can choose to download files for a number of different types of data. You can download them directly for the entire state, or if you add them to your cart, you can actually check out and proceed to download, where you can set an area of interest, choose your data format, and whatever coordinate system or projection rules you'd like to have that data in. As part of that, they've got FME Cloud implemented to be able to handle kind of clipping the data and converting it into the format of choice on demand as users request that. So the first major step in their project was to take their existing data sets, which were all hosted on premises, and move them out to the cloud. So they had many different vector data sets, 300 different ones, and terabytes of raster data that had to be moved up to Amazon. So they used a simple FME workspace to handle that one-time migration of their vector data set. So they took it from their on-premises SQL server to a PostGIS database running on RDS. They were then able to manually move the raster data up to both AWS S3 and AWS Glacier services. Once all the data was up there, they were able to build the rest of their architecture. So everything for their open data portal is hosted on Amazon AWS. So they even included hosting their website from AWS services, and make use of FME Cloud, which is also hosted in AWS. So all the requests for data downloads go through their PostGIS database. So that handles finding the data and kind of retrieving the information that any of the users are looking for. That also includes the raster data. So they have a set of raster footprints stored in that PostGIS database. That includes the URL to where that raster file is stored on S3. Then again, any of the requests that require kind of clipping the data, changing the data format, updating coordinate systems, or anything like that, those are sent to FME Cloud, where a workspace runs behind the scenes to fetch the data from S3, process it, get it into the right format, and then send that out to the user. So for Arkansas, they saw quite a few different benefits of using the cloud to host their open data portal. First one for them was stability. So they were able to make use of fault-tolerant data storage on Amazon. And also by using FME Cloud, they were able to use the services provided by us at SAFE, who could monitor and support that architecture for them to make sure their cloud was always available when needed. In addition to that, they had the ability to leverage the security and compliance and security policies from both AWS and FME Cloud to make sure their data was always stored in a secure way, so they didn't have to worry about any of that. Simplicity for them, so they didn't have to worry about administrating any physical servers or anything to store their data or make sure everything was running smoothly. It's all up in the cloud and handled by either Amazon or FME or a combination of the two. And finally, price. For them, it was about 3 times cheaper than their on-premises deployment. So some details on that here, their costs for on-premises versus cloud. So on-premises, they had to deal with a lot of physical hardware that required maintenance and had costs associated with that, as well as dealing with backups and storing all that information. So they're able to go from a 3-year cost of almost $300,000 down to about $82,000 over 3 years for hosting everything in the cloud. So for them, that was huge, big change. So they no longer had to kind of manage all these physical environments. got all their data up in the cloud and could use that and simply pay for the usage there.
Wow, that was a fantastic tour of the grounds. We not only visited all the different rides, but we walked through a number of great scenarios of use cases for data integration. In fact, let's review exactly what we talked about. We focused first on streamlining operations and the idea of automation being an incredible driver of success for organizations. We then talked about empowering data modernization, replacing legacy systems, connecting systems together, and really just building a more modern infrastructure within organizations. And finally, we talked about cultivating data cultures. We talked about open data portals, and we talked about really the power that connecting systems together and sharing data to those that need it can really drive better decision-making based on data. Whew, that was an exciting adventure today.
Yeah, all right. Yeah, and I want to say thank you everyone for joining us today, and especially thank you to all of our guest speakers who came on to talk about what they've been up to with FME. I hope that served as some good inspiration for everyone out there listening. On that note, if you did find that any of these scenarios or use cases was particularly inspirational, or you can see that you could potentially apply it within your own environment, join us tomorrow in the plenary for part 2 of this talk, where we're going to dive into some tips and tricks for each of these different scenarios. So we're going to get into some different tools that you can use in FME to be able to build up these types of workflows for yourself. So definitely don't miss that one. It'll be a very good, yeah, it'll be great. So at this stage, we've got some time for questions. So if anyone has any questions about anything that was covered in this morning's talk, please do send those in to us. We're going to take some time and we're going to try to answer a few of those questions. And before we just head right into the live Q&A, make sure to head back to the FME World Fair map to see what rides and attractions are at the event you can visit next. You can visit the agenda tab in your left toolbar to see the upcoming sessions for the World Fair.